So let us first understand what are the convolutions. This is an image of one shoe from the MNIST fashion dataset, and this is the representation in the byte values. So you can see the shoe directly as a matrix. So let us zoom into a specific portion to understand how the convolution works. Let us concentrate on one particular pixel. The pixel is the right hand side. It's 88 in center. You can see it there. I will zoom it for you. So if you zoom and you see that the pixel 88 is surrounded by different pixels, and if we consider a 3 by 3 matrix by keeping 88 in the center, then the other values are 77, 130, 72 on the first row, 141 and 172 are the neighboring pixels of 88, and 123, 196 and 229. These three are the third row pixels. Now if we want to apply the convolution, we can use the current pixel value on which we want to apply the convolution. So 88 is the value on which we are applying. We have to take a filter. So since we are working on 3 by 3 data, we can take a 3 by 3 filter. This is one filter where the values are -1, 0, -2, 0.5, 4.5, -1.5 in the second row, and 1.52 and -3 in the third row. The logic here is to multiply each value of the 3 by 3 matrix on the above with the each value of the 3 by 3 matrix of the filter. So if you apply this, the new pixel value for 88 would be something which is a summation of the multiplication of each cell of the matrix created using the 3 by 3 surrounding pixels of 88 and the 3 by 3 filter matrix. So our 88 which was there, after having that filter applied on it, the new value will be created based on this formula. Now let us take another feature which we'll be using in CNN, and this feature is called pooling. The idea of pooling is to reduce the matrix size by concentrating on the important pixels only. So let us see this as a 4 by 4 matrix, and we want to apply a 2 by 2 pooling. So when you say 2 by 2 pooling, let us take the first quarter of the 4 by 4 matrix, the top left corner of this matrix, which is 77, 130, 141 and 88. So if I use this 2 by 2 pooling, then the other matrix will be 72, 15, 172 and 66, and the third matrix will be 123, 196, 223 and 245. The final 2 by 2 matrix out of this 4 by 4 will be 229, 0, 173 and 0. Now you have 4 different matrices which are of the size 2 by 2, and now while applying the pooling, you want to get the maximum value out of the 2 by 2 matrix. So let us take the first matrix, which is 77, 130, 141 and 88. The highest value of this matrix is 141, so I'll pick up 141 from that. For the next matrix, greatest value is 172, so I'll pick up 172. For the third matrix, it's 245, so I will take 245, and for the last matrix it will be 229. So now I have one value which is the largest value amongst the members of 2 by 2 matrix, and I have picked up that value, and then I will form a new matrix out of that, which will be another 2 by 2 matrix, and these are nothing but these are the values which we have derived from the small matrix. So 141 is here, 172 is shifted to the next cell, 245 is set as the first cell of the second row, and 229 is the second cell of the last row. So your 4 by 4 matrix is now converted into 2 by 2 matrix, and the idea is that you keep the features of the data set intake by applying convolution and pooling. While you do this, you are passing the image through multiple layers before it is being sent to the neural network. Let us see how convolution can be seen through the program. So we will be using SciPy's MIS library, and MIS library has a function called ascent. So if you refer it, it loads a picture for the sample example, and this picture is the publicly available picture which they are using for learning the convolution. We are calling the mis.ascent function to load the picture and storing that picture into I. After that, we are plotting the picture. So once you plot the picture, you can see how the picture looks like. As we saw here, in the library the picture is the same which is available. So it returns a picture and that picture is printed using the matplotlib. Then we are transforming the shape of the image, and then there are the filters which you can use. Go with the filter number 2. So I have set that -1, -2, -1, 0, 0, 0, 1 to 1. And remember that this filter is basically a 3 by 3 filter which we are applying on the image. We are performing some mathematical operations to see the convolution in effect, and then we will apply the filter to the image, and after that we will see the picture. So once you run this picture, you will be able to see the effect of the convolution after having the filter. As you can see, the actual picture is now changed, and you can see some lines clearly visible here. Let us change the filter to see the effect. Now instead of filter number 2, let me enable filter 1. So I'm uncommenting the filter number 1, and let us rerun the cells to see the effect of the filter which is changed now. So this was the earlier image. Let us run the filter again, and now you can see the change in the picture because the filter is changed. So you can play with different filters. Okay, so now we will apply the pooling. As you remember, we have seen the 2 by 2 pooling in the slides. So once you apply the pooling, the image size will be reduced. The image which we have seen was a 512 by 512 pixel image. As you can see from the axis, that it ranges from 0 to 512. And once we apply the pooling, the size will be reduced to 256 because we are applying 2 by 2 pooling, and you can see that 256 by 256 pixel image is now created. And the interesting thing is that even the image size is reduced, the important features are still preserved. So you can now use this image which has been filtered with one convolution and one pooling.